Okay, so this is a homework paper, it is a calculator paper, so feel free to use a calculator throughout. So simplify m cubed times m to the power of 4. And when we multiply, we add the powers. And the reason we're doing that is because we've got m times m times m, that's m cubed. And we're timesing it by m times m times m times m, and that's m to the power of 4. So altogether, we have m to the power of 7. Now 5np cubed, all being cubed, means we're going to do 5np cubed times 5np cubed times 5np cubed. We are cubing it. So we're timesing it by itself and then timesing it by itself again. So the 5 times the 5 times the 5, that makes 125. And then I've got n times n, which is n cubed. And then I've got p cubed times p cubed times p cubed, and we saw, as with the example above, that when we times, we add the powers, so p to the power of 9. But a power of a power like this, you can times them, which also gives you 9. Question C, we're going to simplify, and we're dividing the top and the bottom of the fraction by anything they've got in common. So I can divide the top and the bottom by 4, and that gives me 8. I can also divide the top and the bottom of the fraction by q cubed, which leaves me q to the power of 6 on the top, because when we divide, we take away the powers. And I can also divide the top and the bottom by r, and that would leave me with r cubed on the top. All I'm left with on the denominator is 1, so that can just stay 8 q to the power of 6, r to the power of 3. Question number 3, the line L is shown on the grid. Find an equation for L. So for the equation of this line, we need two things. We need the gradient and we need the y-intercept. And the equation of a line is in the format y equals mx plus c. M is our gradient, that's how steep the line is, and c is our y-intercept. So to find out how steep this line is, or to find out the gradient, we would want to make a triangle. And you can make your triangle as big or as small as you like, but you need to kind of try and use 2 points that are going to make it easier for us to work out how much it's gone across, which is 2 in this case, and how much it's gone up, which is 6 in this case. And we're going to do the rise divided by the run. How much it's changed in the y direction divided by how much it's changed in the x direction. So that is 6 divided by 2, and that is 3. We can see this is a positive gradient. The line is going up, and that is our gradient there. If we'd have drawn our triangle here, it would have been 3 up and 1 across, and we would have got the same answer. So y equals 3x plus what? Well, we need to know where it's crossing the y-axis, and your y-axis is this axis here. Where is that straight line crossing that axis? Well, it's crossing it here at -6. So we can lose that plus. We wouldn't write plus minus 6, it's just -6. So the equation of this line is y equals 3x minus 6. Question number 5, complete the table of values for x squared minus x minus 6. Now, when I'm doing this on a calculator paper, I just like to use the brackets for where I'm putting the x. So I'm going to put bracket bracket squared minus bracket bracket minus 6. And each time there is an x, I'm putting brackets on my calculator, and then I can put each of these values into the bracket in turn. So -3 would go in here, and -3 would go in here. And the reason I'm putting it in brackets is because then your calculator knows you've got a negative number and you're squaring it. If you did -3 squared in your calculator without brackets, it's going to tell you that that's -9, because it's doing 3 squared and then making it minus rather than squaring -3. So trust me on that one, put it in brackets. Okay, so doing that with -3 gives us an answer of 6, so we know we've typed it in correctly. We're then going to use that left arrow. So on your calculator, somewhere near the top, hopefully you've got a button that looks something like this. Use that left arrow to go back and change both of those values to be -2. And if we do that, we've got -2 squared minus -2, add -6, and that gives us 0. So we know that that one's 0. Now again, use that left arrow, go back and change both of those numbers in the brackets to be -1, and that gives us -4. We've got 0, so let's go back and change both those values to be 1. Doing that gives us -6. Then go back and change them to 2's, and that is -4. and then go back and change them to 3's, and that is 0. So we've now got lots of coordinates that lie on this graph, and we know it's a quadratic graph because we've got that x squared. We know it's going to make a parabola, either a positive parabola like that, the smiley face shape, or a negative parabola like this, but we can see from the coordinates we've got and the fact that this term is positive that it's going to be this way up. So let's plot each of those coordinates. I've got minus 3, 6, so minus 3, 6 is there. I've then got minus 2, 0, which is there, minus 1, minus 4, which is down here, 0, minus 6, 1, minus 6, 2, minus 4, and 3, 0. And we can see it's making that quadratic shape. We're then just going to try and draw a smooth curve that goes through all of those points. Now, really important when you get to here, it needs to dip slightly below. Don't have a flat bottom. And then smooth curve going through all of the points. If you miss a point, use a pencil and then rub it out and redraw it, okay? It needs to be accurate. So there we go, 4 marks for that one. It then says use your graph to find estimates of solutions to the equation. Now this x squared minus x minus 6 is what we've just drawn on the graph. So this is essentially saying to you, when does your quadratic equal minus 2? Now we drew y equals x squared minus x minus 6. So when is y minus 2? So looking at the graph, we're looking for when y is minus 2, and that line would be here. That is the line y equals minus 2. So when does the quadratic graph equal minus 2? Well, it equals it in 2 places, here and here. So then we're just going to draw lines going up to the x-axis to see what that value is, and we can see we've got minus 1.5 and 2.6. So I would put both those values on the answer line, minus 1.5 and 2.6. Okay, question number 7, and we need to enlarge shape A by a scale factor of 1/3, centre 0, 1. So they've already given us that value there. Scale factor 1/3 means 3 times smaller. If you're making something 1/3 as big, it needs to divide by 3. So at the minute, the gap from the centre of enlargement to this bottom left-hand corner of the shape is currently 3 diagonal squares. Now we want to make that 3 times smaller, or 1/3 as big. So instead of going 3 diagonal squares across, instead of going 3 across and 3 up, we're going to go 1 across and 1 up. And that is going to be the new gap from the centre to the start of the shape. So that is my new bottom left hand corner. That's that point there. Now this shape before was 6 squares tall. Going from here to here, it was 6 squares tall. We're making it 1/3 as big, so it's only going to be 2 squares tall. It was 3 squares wide, so we're going to go across by 1. It was 3 coming down, so we're going to come down by 1, and always do any diagonal lines last, but we can see that it's going to be that. So that would be our shape. That is an enlargement. Now you might find it helpful to draw lines in just to check. Always with an enlargement, all of these coordinates of matching points, of corresponding points, should always match up. And there we go. Should we draw it in a nice, give it a bit of colour. There we go. That is the shape that we were after. There we go. Question number 9. Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. So they're not telling us the interest rate, but we know it's X%. At the end of the first year, the value of Jean's investment is £12,336. In the second year, the rate of interest is X divided by 2, so half as much. What is the value of Jean's investment at the end of 2 years? So with compound interest, what we would normally do is we would take £12,000 and we would times it by whatever the interest was added on to 100%. So let's say it was 3% interest. We would do 100%, add 3%, and we would times by 1.03, and that would get us 12,336, or whatever the answer was. But in this case, we don't know what the interest is. So I'm going to say that we're just timesing by y. Now, to get that interest rate, we need to do 12,336 divided by 12,000. And that gives us, just type that in my calculator, 12,336 divided by 12,000 is 1.028. Now, that does not mean that that's the interest rate. We saw that if we did 100%, add 3%, we would have timesed by 1.03 because that's 103% as a decimal. Here, we've timesed by 1.028. So that means that the interest rate, x would equal 2.8%. So now, in the second year, we get half as much, or Jean gets half as much. So in the second year, she's getting 1.4%. We've divided that by 2, as they've told us to do in the question. So now I'm going to take the £12,336 and I'm going to times it by, well, now I want 100% of the money I had, and I want an extra 1.4%. So I want 101.4%, which means I'm going to times by 1.014. 12,336 multiplied by 1.014 is 12,508.704. Because it's money, we're going to round to 2 decimal places, so 12,508.70. Okay, question number 11, and we've got functions. F and G are functions such that f of x is 2 over x squared and g of x is 4x cubed. Find f of minus 5. So this is telling us to make the input into the f function minus 5. So this bit, people often get confused by this bit. This is just kind of introducing the function. It's saying I have a function and I'm putting x into it, and g of x is just because we've already used f. So this is a different function. So don't worry too much about that side. That's just labelling the functions. If we're then told to do f of minus 5, it's saying put minus 5 into this function. So it would be 2 over minus 5 squared. And again, just like we saw when we were drawing the quadratic, if we're squaring a negative number, we're going to want to put it in brackets if we're typing it in our calculator. But we should know that a negative times a negative, if you're timesing a negative number by itself, it's going to be a positive. So this is 2 over 25. And for the next part, we have a composite function. So this means we're going to put 1 into the function g, and then whatever our answer is, we're going to take that and put it into f. So the first thing we're going to do is g of 1, which is 4 lots of 1 cubed. I'm just looking at this function and I'm putting it in. So 1 cubed is 1, times it by 4 is 4. Then I'm going to take that answer and put it into f. So now we're doing f of 4, which is 2 over 4 squared, which is 2 over 16. And you can write 2 over 16 on the answer line, or you can simplify it, entirely up to you. Either of those would get full marks. Okay, question number 13, and we've got circle theorem here. It says A, B, C and D are points on the circumference of a circle, centre O. FDE is a tangent to the circle. Show that y minus x equals 90. Okay, so we know that a radius and a tangent meet at 90 degrees. So where I have this radius OD and I have a tangent FDE, I know that that there is a right angle. I also know that I've got the alternate segment theorem. So let's just use this straight line tool. Let's do it in green. Whenever you have a triangle that is touching a tangent by its tip, all the T's. So there's your triangle and there is your tangent. Whatever angle is made over here is equal to the angle that is made between the edge of that triangle and there. So you'll often see it drawn a little bit nicer, maybe not off to one side quite as much, where, oh, that's drawn badly. This angle is equal to this angle, and this angle is equal to this angle. And the edges of the triangle have to be touching the circumference of the circle. So we now know that this angle here, y, is equal to this angle here, which is angle BDE. So that is x add 90. And then if we rearrange that, we can take x away from both sides, then y minus x equals 90. That's just one way to do that question. There are lots of other ways. What did I use? I used this circle theorem. So using the alternate segment theorem. That's the name of that one, where you've got that triangle on its tip. We also use the fact that a radius and a tangent meet at 90 degrees. So those were the two rules that we used there. Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 take away 110 is 90. Is Dylan correct? Well, given that y is an angle inside a triangle, it cannot take a value that is that large. So no. So no, because angles inside a triangle add to 180 degrees and 200 is larger. Great. Okay, question number 15. A darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45, and they've already filled that in for us there. If they win on Saturday, the probability that they will win on Sunday is 0.67. Great. So if we're coming up this pathway, then the probability of us winning is going to be 0.67. If they do not win on Saturday, so that means we're coming down this pathway, the probability that they win on Sunday is 0.35. Now, we don't have any more information, but we don't need it because we know that probability always adds to make 1. So the chance of me taking this route or this route is going to add to make 1, which means this one is 0.55. And with Sunday up here, I need this to be 0.33 so that these two also add to make 1. And this one's going to be 0.65 again so that these two also add to make 1 because we are certain that we're going to take one of those paths. Okay, we're then asked to find the probability that the team will win exactly one of the two matches. So we are interested in them winning one match, so for example taking this path, but not the other one. Or we're interested in them taking this path, not winning the first match, and then winning the other match. We don't want any of the other pathways because we don't want them to win twice and we don't want them to lose twice. We just want them to win exactly one match. Okay, now to find the probability of those things happening, we times along the branches and we add the ones we want. So we want those two. So this is going to be 0.45 times 0.33. Timesing those values together, 0.45 times 0.33 is going to be 0.1485. And then with the pink pathway there, I've got 0.55 times 0.35, and that is 0.1925. We then don't mind if it happens that way or if it happens that way, so we can add those two answers together. And that is 0.1485. Add 0.1925, which is 0.341. And that is our answer. Question 17, and we have a histogram. The histogram shows information about the times taken by some students to finish a puzzle. Complete the frequency table. And underneath we've got a table here, and we need to know the frequencies. Now, I love a histogram. It comes up every single year, or it has done so far. The special thing about a histogram is that up the side, we don't have the frequency. The frequency is actually found by the area of each bar. So the area of the bar is how many people are in that category. And to get the area, we're going to do base times height, just as we normally would for a rectangle. So this width down here goes from 0 to 5. And 5 times 0.8 is 4. And they already had that one filled in on the table. Down below, we can see the frequency is 4. Now the next category goes from 5 to 15. So it has a width of 10 and it has a height of 0.4. So that also has an area of 4, and that would be the next value in my table. For the next bar, it has again from 15 to 25, so a width of 10, and it has a height of 0.6, which makes it 6 in terms of the frequency. The next bar is 5 wide and 1 tall. 5 times 1 is 5. And the last bar here is 20 wide. It goes from 30 up to 50, and it has a height of 0.2. So we're doing 20 times 0.2, which is 4. And that's our frequency completed. Part B says find an estimate for the lower quartile of the times taken to finish the puzzle. So the first thing we need to do for the lower quartile is work out how many people there were. So I've got 4, add 4, add 6, add 5, add 4, which is 10, 15, 19, 23. Now if I want to know where the lower quartile is, I would add 1 and divide by 4. For the median, we would add 1 and divide by 2. But for the lower quartile, I'm going to add 1 and divide by 4. So 23, add 1, divided by 4, gives me 6. So I'm looking for the 6th person. Where is the 6th person and what is their time? So there are 4 people in the first category. And then there are 4 people in the next category. So I want to go halfway through this category. And looking at the graph, we can see that that happens here. If I've got 4 people in the first category and 4 people in the next category, we can split that to be 2 and 2. So we're going to say the 6th person is there. So we're going to say 10 is the time taken in minutes. That's halfway through that second category, which is where the 6th person would be. Okay, question number 19. Shape S is 1/4 of a solid sphere centre O. The volume of S is 576 pi centimetres cubed. Find the surface area of S. Give your answer correct to 3 significant figures. You must show you're working. So if they give you the answer and they're telling you that that is the answer to volume, I want you guys to write down how you would come up with that answer. So we would do 4/3 pi r cubed. But then we would divide it by 4 because this volume is only for 1/4 of the whole sphere. It says it's 1/4 of the whole sphere. So we would do 4/3 pi r cubed, but that would give us an entire sphere, and we don't want an entire sphere, so we would then divide it by 4, and that would equal 576 pi. So now we've got that information, we can work backwards and try and get what the radius was. So the first thing I'm going to do is times both sides by 4. So 4/3 pi r cubed equals, and I'm just going to times that by 4, and I'm going to leave it in terms of pi because that's there's no point getting that involved. And now I can divide both sides by pi, so let's just get rid of it like that. So 4/3 r cubed is 2,304. I now want to divide both sides by 4/3. So 2,304 divided by 4/3 is 1,728. And then to find out what the radius is, we need to do the inverse of cubing, which is going to be the cube root. So cube root, which is normally shift and cube on your calculator, that answer, and that is 12. So the radius is 12. We now need to work out the surface area, and we're given that the surface area of a sphere is 4 pi r squared, but again that would be for the entire sphere. We actually only have 1/4 of the outside shape, but we do have this part and this part, which would actually make a circle. So that circle would have an area of pi r squared. A normal circle, if we want to know the area of it, we would do pi r squared. So I'm going to do 4 pi r squared for the area of the outside, the curved part, divided by 4, and then we're going to add on another pi r squared. But 4 pi r squared divided by 4 is pi r squared, and then we're adding on another pi r squared. So the easiest thing to do here is just to do 2 pi r squared or pi r squared and double it. But if you didn't do it that way, that's absolutely fine. It might just take you a little bit longer. So 2 times pi times 12 squared, because don't forget we've worked out that the radius here is 12 from the other part of the question. So 2 times pi times 12 squared is 288 pi, but we were asked for it to 3 significant figures, so press that SD button on your calculator, and that is 904.778 and so on. So to 3 significant figures, that's your first significant figure, your second significant figure, your third significant figure. The 7 rounds up, so 905 would be your answer for 5 marks. Question number 21. Jackson is trying to find the density. Okay, I'm immediately going to draw my density, mass, volume triangle in grams per centimetre cubed of a block of wood. The block of wood is in the shape of a cuboid. He measures the length as 13.2, correct to the nearest millimetre, the width as 16.0, correct to the nearest millimetre, and the height as 21.7, correct to the nearest millimetre. He measures the mass as 1,970, correct to the nearest 5 grams. So this is a bounds question. And if we've rounded correct to the nearest millimetre, we want to go half a millimetre above and half a millimetre below. We're in centimetres here, but that's okay. We know that a millimetre is 0.1 centimetres, so half of that is going to be 0.05. So I'm going to put the length as 13.25 and 13.15, using the upper and the lower bounds there. The width is going to be 16.05 and 15.95. So see, even though it's a 0, that has been rounded to the nearest millimetre, so we still need to go 0.05 above and below. And then the height is 21.75 and 21.65. And the mass is 1,970, correct to the nearest 5. Now if it's to the nearest 5, again we need to half that, divide it by 2, so we're going to go 2.5 above, so 1,972.5 and 1,967.5, 2.5 above and 2.5 below, always half what you're rounding to. By considering bounds, now this means we're going to get the absolute biggest answer we can, and then we're going to do the absolute smallest answer we can, and then we're going to see by how much they agree. Now, if we are calculating the density, we would be covering up this and doing mass divided by volume. So for the upper, density upper, we are doing the biggest mass, so mass upper, divided by the smallest volume. Because remember, when you're dividing, you want to divide by as little as possible to keep your answer as big as possible. And so the density lower is going to be the mass lower divided by the volume upper. Okay, so let's get the absolute smallest volume we can, and that's going to be the smallest length, the smallest width, and the smallest height. So let's go for that over here. The density upper is the biggest mass, which is this one here, 1,972.5, divided by the smallest volume, which is 13.15 times 15.95 times 21.65. Typing that all in my calculator, and you can do that individual calculation if you want. I'm just saving time. So 1972.5 on the top, and then 13.15 times 15.95 times 21.65, and that gives us 0.43438288506. And I'm just going to write it all out for now, just so that it's easier in a minute. And then density lower is going to be 1967.5 divided by, and then it's going to be the bigger ones, 13.25 times 16.05 times 21.75. And again, typing that in my calculator, 1967.5 divided by 13.25 times 16.05 times 21.75. And that gives me an answer of 0.42536775546. Now is the bit that is by considering bounds. So this bit here, by considering bounds, means that we get the absolute biggest answer, the absolute smallest answer. Now, if I was to round them both to one significant figure, they would both be 0.4. So that's okay. If I was to do two significant figures, this one would round to 0.43 because the next numbers are 4, so that would round down. And this number would actually also round to 0.43 because the next numbers are 5, so this would round up. So I would say that my answer is 0.43 because both bounds agree to two significant figures, and that would be my final answer. I hope you found that helpful. Any questions, please let me know in the comments and I would be happy to help.